Welcome to our lesson 5.2 in chapter 5, which is all about taking all those algebra skills we were practicing in 5.1 and applying them to verifying some trigonometric identities. Now, we did this a little bit in chapter 4, but now we have a ton more under our belt, so there's going to be a few more things kind of take into consideration. So the first thing, we're going to kind of skip those guidelines on the top of the page for now. So on that bottom half of the first page, it's just another iteration of a lot of those useful identities for you guys, so you can have that as a constant reference as you're doing the homework. So as you're doing the practice, as you're even doing the notes, having these nearby if they're not memorized will always be helpful to go back and reference. Now, what does it mean to verify an identity? Well, we're going to kind of skip just to the top of that second page and take a look at an idea of what does it mean to verify an identity. So this right here is an example of one identity, which we know to be true. So it's our job to prove one side will simplify down to equal the other. Now this is where we're going to pull in those guidelines from the first page. There's a few steps we can take to kind of make our lives a little easier. The first thing is always do one side of the equation only. We're only going to ever work on one side of the equation. And specifically, we're always going to pick the more complicated side of the equation. So it's always easier to kind of simplify down than it is to produce a bunch more stuff. So for example, this number 1 on the second page, which we'll do in a minute, this left-hand side, well, it has a fraction, it has multiple trig terms, it has that addition or subtraction up top in that fraction, a lot more going on here than just this sine squared. Now, if you're never sure exactly which side's more complicated, then think about what would be more challenging. Somehow turning the sine squared into a fraction, or maybe simplifying some of this fraction to be just one sine term. So step 1, always start with that complicated side, and we're only going to work with that side. Step 2, and this is what we did with simplifying in 5.1, is anytime we see we can factor something or add fractions or take a square root or create a monomial denominator, aka just a singular value in the denominator like we have right here, then go ahead and do that. Those are going to be our useful tools to get the most simplification happening at once. The third tool is to use any of our fundamental identities. So that's exactly what's on the bottom half of this first page of notes. We had some on 5.1. Anytime we can make those substitutions, and we know really often these Pythagorean identities really come into play, so especially those, we want to jump the gun and always make those changes, because anytime we have, say, a Pythagorean identity, let me bring this back up. So say for this first one, we typically saw it as, say, 1 minus cosine. So if we saw 1 minus cosine squared, we can change that addition of two terms or subtraction into just 1. It's always easier to simplify. Now the fourth step, if nothing's really getting us anywhere yet, same with simplifying, the next little trick is to get any and everything that you're working with in terms of sines and cosines. So even if it's a secant, get it in terms of cosine. If it's a tangent, represent it in sine and cosine. You'll get a lot more canceling happen when you get that, and that always helps out. And then that last tip is always try something. So if you're just kind of staring at the verification, it's going to be really hard to do that mental math. But if you give it a shot and start working at it, manipulating it, you can start to see some of that development, just like we saw in 5.1. So we're going to take these ideas, we're going to do the entire next page together, numbers 1 through 4, and then you guys will give 5 through 7 a shot on your own. Coming on to that second page, with number 1, step 1, we already identified that more complicated side, which was that left-hand side. So we want to do whatever possible on this left-hand side to get it to be equal to sine squared theta. Well, before anything else, I do see it's a secant squared down below. We could change that to a cosine squared and bring it up. However, like I already said in that first page, I'm starting to recognize a Pythagorean identity right off the bat. So I see that secant squared theta minus 1, but that's a Pythagorean identity for us. That just gives us tangent squared theta. So now we got that binomial term, right? So it's by addition or subtraction into just one term. That's going to allow us to have some cancellation. And we're getting there. We now have just a monomial over monomial, so things could cancel, but we do still have a fraction. So I want to remove that fraction with one of our fundamental identities. This is really a tangent times 1 over secant squared. But I know 1 over secant, right? So 1 over secant, that's going to give us just a cosine back. And then that holds true even if it's squared. So I'm going to get this secant represented up top in line with that tangent. So 1 over secant squared gives us a cosine squared. Now we got rid of that addition subtraction. We got rid of the fraction now. And we're almost there, but not quite. So next in line, something I'm going to do, especially when you get down, when you feel like you're getting closer and there's less involved, I'm always going to have that fallback on get everything with cosine and sine. So cosine squared, already handled. That tangent squared, I'm going to represent in terms of sine and cosine. So I know tangent is sine over cosine. So tangent squared is sine squared theta over cosine squared theta. And now this is going to be multiplied by a cosine squared theta. And hopefully we're already seeing it. We get that cosine squared top and bottom. That's going to cancel out. And that leaves just that sine squared theta. So that is an example of what it means to verify an identity. Now, if you're doing it by hand, we always have room to kind of take a different path. Maybe your first step is you bring the secant up. That's totally fine. On a WebAssign, some of those problems might be more guided, where it's forcing you in a direction and have you kind of fill in the gaps. So kind of keep that in mind. So you're not wrong taking it a different way. WebAssign might just direct you differently. So let's move on to number 2. Number 2, again, we're given this identity. We want to verify it. So step 1, which side's more complicated? And this one's kind of a gimme, right? The 1 or this whole mess. Absolutely, this whole mess has way more going on. So let's try to get this to equal to just 1. Well, I'm going to do this one actually 2 ways to kind of reiterate what I said above, but there might be multiple ways about it. So one way I'm going to go about this is I'm going to look at that denominator first. That cosine squared times secant squared. So remember, cosine, it's reciprocal as secant. So that denominator is really just saying cosine squared theta times 1 over cosine squared theta. So if you ever have a cosine times a secant, or cosine squared times a secant, we're going to get that to cancel out. So with that, our entire denominator is just going to give us a 1. So we'll be able to remove that denominator, right, when we divide by 1. But before I even do that, I'm looking at the top with an addition or subtraction of squared functions. Again, here we go one more time. I'm seeing a Pythagorean identity up top, where I know sine squared theta plus cosine squared theta gives me 1. Well, lastly, right, just quick division, 1 divided by 1 is 1, and that's exactly what we're trying to prove. So one thing to look out for, Pythagorean identities, always. And then something we know but we haven't seen a ton is this idea of cosine times secant. This would be the exact same as tangent times cotangent. This would be the exact same as sine times cosecant, right? Because you're just multiplying by the reciprocal, which always gives you 1. So that's my first way of solving number 2. So we're going to take a look a little bit different way. So another way to go about it, and you might work it out this way, is you might recognize that the top is that Pythagorean idea early on, which is totally fine. So maybe we recognize that first. So say we're over here, we recognize that that numerator is Pythagorean identity equal to 1. And then we know from there that 1 over secant is cosine, or 1 over cosine is secant. So I'm going to take the 1 over cosine squared right here and rewrite it as a secant. So it's really going to be secant squared theta from the 1 over cosine. And that's going to be divided by, well, this extra secant that's left over down below. Well, just like we've seen before, numerator and denominator are identical. Those are going to cancel out, leaving us with exactly 1. So slightly different way than I did it the first time. Both ways we get to verify it. Neither are wrong, and honestly, neither is more correct. So just keep in mind there will always be more than one way we can kind of go about it, what we approach first. But again, just Web of Science probably going to funnel you into a certain direction. All right, let's move on down to number 3. And again, when we're verifying these, we're not having to introduce new skills. We're using everything from 5.1 and chapter 4. And now instead of guessing what we simplify it to, we're more or less being told what to simplify it to. So for number 3, starting off right, which side's more complicated? And although this is a secant squared with a random 2 in front, anytime I'm seeing fractions, anytime I'm seeing addition on top of that instead of multiplication, I'm going to go with that side being more complicated. Now, we had almost identical problem to this in 5.1, where we're just asked to add some fractions in this similar sense. And when we add fractions, right, we need a common denominator. So this first fraction is going to gain a factor of 1 plus sine theta. And the second one's going to gain that factor of 1 minus sine theta. So for the first, it's going to be 1 plus sine theta. And now all of this will be over our common denominator. And then this second one gains the 1 minus sine theta. Now we got a couple things going on here. We got that 1 and the 1. We're getting like terms. So that's going to give us our 2, which we should be kind of stoked to see, right? We're getting a 2 showing up, which we are going to need in the end game. So that's good to see. And again, in the numerator, we have a positive, but then a negative sine of theta, which is just going to cancel out. Now, shown in the same step, however, I want to work on the denominator a little bit. And in the denominator, I want to clean it up. There's a lot going on here. But if we do also recognize a little something from that 5.1, 1 plus x, this is just a difference of squares working backwards, right? So when we FOIL this in the denominator, all we get back is a 1 squared, which is 1, minus a sine squared theta. So now we got a 2, that's showing up, we like it. We have 1 minus sine squared in the denominator, and that sine and secant aren't quite related, right? Sine and cosecant would be. But once again, we're going to see one of the most common tools we're using in this is examples of the Pythagorean identity. And that's exactly what we have right here in the denominator. 1 minus sine squared theta from our Pythagorean identity. Right? If we subtract that sine over, we get cosine squared theta. So we have 2 up top, cosine squared theta down below. And now we're right on track, right? 1 over cosine squared theta. And this is what it means to have it as a monomial. We can now take reciprocals of this really easy. instead of what we had in the line before. And then we know that reciprocal of cosine, we'll get that 1 over cosine as secant. Now again, if you took this in longer steps, or you're able to kind of cut some out of the middle while you're working on it, as long as you're getting that process down, you're going to be doing it the right way, following those steps on that first page. So just kind of keep that in mind every time you're going to do the number 5 through 7 on the practice and also the homework. But we're going to do one last problem together, and that is number 4. So take a minute, number 4. Identify what side you think would be the more complicated side. Now, hopefully you pick the left-hand side. We have a binomial. We have, on top of that, this is just tangent, and this is cosine, so 2 different functions, and this is just a negative tangent squared. So I do want to start on that more complicated side. Now, take a minute, look at this, or even just a few seconds. Instinctually, when we see something of this form, say x squared plus 1, y squared minus 1, instinctually we see those parentheses and binomials, and we want to jump on factoring, which I'm sure you could do and still end up at tangent on a far longer path. But every time we see a squared function, we should always be thinking Pythagorean identities. And lo and behold, once again, we have one of them showing up for sure. And we don't quite have one showing up here, right? We need this to be a 1 minus cosine squared. But we learned in 5.1, just a reminder, we could just factor a negative out and it gets it in that right form. So for starters, we have that tangent squared theta plus 1. That's just secant squared theta. And now I'm going to factor a negative 1 out of this second term. And when I do that, it'll change it to 1 minus cosine theta. So again, that negative is from that second term, because now this is in a form that's Pythagorean identity. So we'll make that substitution. From here, right, we're going to end up with a sine squared. So you have minus secant squared theta times sine squared theta. And we're getting close. We got that negative that's floating out front, so that's good. We got that both these functions on this side are squared and the tangent squared. That's looking good. Now again, kind of pause, think to yourself, how could we get a tangent out of this? And if you're not quite sure, then remind yourself, what is tangent? What should it even look like to make it equal to tangent? So a little reminder, right? Tangent for us is just sine divided by cosine. So tangent squared is sine squared divided by cosine squared. Well, we have a sine squared up top. So I would jump on doing one of those rules from that very first page, which is get everything in terms of sine and cosine and see if you can see that next step. So I'm going to rewrite secant as what we know it to be as 1 over cosine. So this negative is going to stay up top with that sine squared. And now secant squared theta is just 1 over cosine squared theta. Well, now hopefully we're starting to see what we're looking for, right? We got that sine over cosine. They're both squared. And we can rewrite that as tangent squared theta. And again, we got that negative we factored from that first line coming along with us. So again, that first page that has those 5 rules or so, those are really good to follow. Find that complicated side, right? Start there and only work on that side. Always look out for those Pythagorean identities. Those come in a ton. So if we can see them, go for them. Anytime we're dealt with fractions, get a common denominator, right? And get that into one whole fraction like we saw in number 3. And kind of that last one, it's always a kind of a fail-safe to kind of reset yourself and how you're viewing it, is get everything in terms of sine and cosine. a lot of the times we'll start to see some canceling and that pattern show up. So that's it for the ones we're going to work together. Now I'm going to have you guys give it a pause, give numbers 5, 6, and 7 a shot. And if for some reason you're not sure which side is going to be more complicated, then in a minute you can kind of replay, and I'll kind of show and underline which side is more complicated for those three. So if you need that little extra hint on 5, 6, and 7 on kind of which side to start with, for number 5, our left-hand side is the more complicated side. I would start there. For number 6, again, multiplication we actually like. Things can cancel out, which is really nice, or we can work with reciprocals, but addition is less user-friendly. So that's going to be our more complicated side for 6. And then for 7, it's a close one, right? So we see that addition happening. So if we're using that same logic, we go, oh, well then, Hoffman, we should do the left. However, that right-hand side, having not only a fraction, but a fraction with this kind of ugly denominator, I will say is the more complicated side. And then one last hit for number 7, if you need it, I might clear that denominator as my first step. So again, use those hints if you need them, and then in a second we'll come back and work. So wrapping up this shorter lesson of 5-2, hopefully you gave it a pause, and numbers 5 through 7 a shot. Really good practice. Now, again, you may have done it slightly different. You might have had a one step shorter, one extra. As long as you're getting that equality holding true all the way through, then you're getting that verification correct. So here's how I approach number 5. Number 5, again, said that left-hand side was going to be more complicated. And I had no identities, and I didn't have much to go on, so I kind of fell back on to get everything in sine and cosine right away. So that tangent was sine over cosine. Cosecant is 1 over sine. But now we have those sines canceling, leaving just that 1 over cosine, which, short and easy, right? Reciprocal function, that's just secant of theta. Now moving on to number 6. Again, left-hand side was more complicated. And also, one more time, I didn't have much identities or anything to really work on. So I fell back onto, hey, change everything to sine and cosine, see if I could see a pattern. Well, tangent sine over cosine, cotangent cosine over sine. I did create 2 fractions, which is a little tougher to deal with, but it is all sine and cosine, so I got that common denominator. So that first term gained to sine, so we get sine squared. Second term gained to cosine, cosine squared. And now, like we've seen a ton already just on this one, right? Pythagorean identity up top, that changes to a 1. So we get 1 over cosine sine. Then I just added this extra step for you to really see. We could break that up as 1 over cosine times 1 over sine. And then that very last step is those reciprocal functions. That's just secant theta times cosecant theta, which is exactly what we're looking for. Now, wrapping up the very last one, number 7. Number 7 was the toughest, probably, of the notes. So for 1, it's kind of tough to decide which side might be more complicated. So I gave the hint I would have gone with the right-hand side, kind of clear up that fraction. And we also haven't seen it a ton so far in 5.1, but we did see it a couple times in, 5.2, but in 5.1 we did see that we could clear up that denominator by multiplying by its the conjugate, right? Just like complex numbers or dealing with radicals. So we multiply by the conjugate, top and bottom. Well, that'll clear up that denominator. So we get the 1 minus sine squared, which again, Pythagorean identity, giving us that cosine squared. And then once I make that change, I see we get some canceling with the cosines. We lose that 1 up top, and we only lose 1 of the ones from below. So we still have that cosine in the denominator. Well, give it a rewrite, kind of freshen it up. We get 1 plus sine theta up top over cosine theta down below. And if it's a monomial in the denominator, just one term, and we have multiple up top, we can always break those up over that same denominator. So we got 1 over cosine That's where we're getting our secant we're looking for. And then sine over cosine, which pulls up that tangent. So that wraps up our 5.2. Again, if for these three problems you did it slightly different, still got there, that's awesome. You still have that verification down. Just know if we're working on WebAssign, it might be a little more directed in what it's looking for.